launching a new weather satellite, and fixing a spacecraft in interstellar space. You're listening to Are We There Yet?, the radio show exploring space exploration. Hi, I'm Brendan Byrne. The latest GOES weather satellite launched into space last week. We'll speak with Lockheed Martin's Jagdeep Shergill about how this satellite will change the way we look at weather here on Earth and also weather in space. Then, Voyager 1 is back online. Late last year, a technical issue prevented the spacecraft, launched in 1977, from communicating with Earth. But now Voyager 1 is back to talking after engineers repaired it while it was 15 billion miles away. We'll speak with Voyager's Kareem Badruddin about the fix and what's to come for the decades-long mission. That's ahead on Are We There Yet? The fourth and final satellite in the R series of the Geostationary Operational Environmental Satellites constellation, or GOES, is now in space, and it will soon be ready to monitor and analyze weather patterns on Earth and in space. Here to talk about the satellite's capabilities and how it will advance weather tracking and forecasting systems is the Program Director of GeoWeather at Lockheed Martin, Jagdeep Shergill. Jagdeep, welcome to the show.
Thanks for having me.
So an incredible launch last week, right? Tell us a bit about the ride that this satellite took to space.
Yeah, the Falcon Heavy is an amazing rocket to watch and get to see those boosters come back and land. So that was probably once in a lifetime type of event to actually see in person and listen to. So we launched at about 5:26, I believe, on the dot. We had our launch window moved by 10 minutes due to weather, but we found the perfect little pocket and got up. Since then, the spacecraft got a ride from the Falcon Heavy up to its injection orbit. We separated from the launch vehicle about 4.5 hours after launch. And about 5 hours after launch, we did our phase 1 deployment of the solar array. At which point we were off battery power, which is a huge milestone for the spacecraft to be able to actually pull power from the solar rays from the sun and not be draining our batteries. Since then, we've been working on transfer orbit, which means taking the satellite from that injection orbit where the rocket put us into fully geostationary orbit. So we've done a few burns of our main engine called the LAE that have been successful, and we've got about 3 more burns planned before we get to geostationary.
And this is quite a big satellite, is it not? Is that why you had to use the Falcon Heavy to get it to this really high orbit, and also it's massive?
Exactly. Yeah. I think we did the planning for a Falcon 9, but in the end decided to go on a Falcon Heavy because the spacecraft is over 11,000 pounds, fully fueled, and about the size of a small school bus. So yes, it takes about a Falcon Heavy to get us there.
And before we talk about its capabilities, the weather window that you got through, were you all utilizing some images and data from the current GOES system to make that call to launch?
Yeah, I imagine they were using prediction models that use some GOES data. We actually got a really cool view. I think it's out there in different social media venues of the view of the launch from our GOES 16 spacecraft. So our GOES 16 spacecraft, which was originally the first of the GOES-R series, the GOES-R spacecraft, got a view of the launch from Florida, showing the lightning that was just descending upon the launch pad. So it really illustrated, one, the power of these satellites and the imagery that they can capture, and two, just that perfect pocket of window that we got for that launch last week.
I'm sure those GOES satellites are eagerly awaiting their little sibling to get into orbit. So let's talk about what comes next. Once it does get into that geosynchronous orbit, what will GOES-U do, and why are our weather forecasters so excited to have this piece of technology in orbit?
So the GOES-R spacecraft, this entire series, is our nation's most advanced fleet of weather observation satellites. And the unique thing about this set of weather observation satellites is that they're geostationary. So they're looking at the same spot on Earth. They're watching the weather come in. They're in that time span where we can see just the minor changes whether a storm is increasing intensity or decreasing in intensity, the lightning strikes, those have been a key enabler of being able to predict the intensity of the storm. And not just the lightning that goes from the cloud to the ground, but the cloud to cloud lightning. That's been a key predictive indicator on the intensity of storms. So these satellites, the data that these satellites are providing are enabling the better forecasts to be able to save lives and property here on Earth. In particular, on GOES-U, we also added a seventh instrument, a solar pointing instrument called the compact coronagraph, that's going to be able to see visually coronal mass ejection, CMEs, coming off the sun, which again are going to be able to tell us solar weather that can affect our power grids here on Earth, the environments that our astronauts are seeing as they're doing out in the environment of space. So that kind of data is also invaluable for our readiness.
This particular satellite, what will it be looking at? What is it pointing down at?
So GOES-U, which is now called GOES-19, will, after we've done on-orbit checkouts, it will be replacing the GOES-16 spacecraft that's over the East Coast. So it will be, once operational, it will be renamed GOES-East. Yes, there's 3 different names for this one spacecraft. It will be renamed GOES-East and see the weather coming off the Atlantic Ocean that's hitting the east coast of the United States, as well as further down into South America as well.
So it will be staring at me, basically, here in Orlando, Florida. Yeah. Okay, very cool. Well, I do know that we do have a lot of storms here, a lot of lightning. So that lightning mapping is actually really interesting. What kind of instrument is that? And is it only able to track this from above? Is that why this is so revolutionary?
Yeah, we can only see the cloud-to-cloud lightning from above, from these geostationary orbits. And again, because we're constantly watching the same spot, we can see second by second, minute by minute, how the weather's changing over the spots. So the lightning mapper that's flying on the GOES-R series, it's the first geostationary lightning mapper ever flown. And it's providing the information for thunderstorms and tornado warnings as well. It provides information to track tornado warnings. It can also provide information on wildfire detection, early wildfire detection. So imagine a wildfire that hits out in the middle of nowhere where people haven't put eyes on it, aren't seeing the smoke from it. So Lightning Mapper, along with the Advanced Baseline Imager, can spot these early signs of wildfire and get first responders out to those areas immediately. And yeah, so it's providing a lot of that early detection for storms.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with Jagdeep Shergill, the Program Director of GeoWeather at Lockheed Martin, about the GOES-U satellite that will monitor weather in space. The satellite will watch Earth's weather, but also monitor space weather. And is it just optical imagery, or are there other instruments on there that are tracking these kind of phenomena that impact both severity of weather and forecasting of weather?
Yeah, the 2 main instruments I mentioned, the Lightning Mapper and the Advanced Baseline Imager, are optical instruments, but we have other instruments on board as well that are not optical. We have SICE and EXIS that are watching the space environment. So watching detecting for electromagnetic storms that might be coming in. Again, might be caused by the solar weather that our solar instruments are also picking up, but they're able to measure the electromagnetic activity, not just by imagery, that is out in space.
And why is that weather important for us to be forecasting and modeling and predicting?
Yeah, all space weather impacts the Earth at some point. So it's important, again, like I mentioned, the space weather, solar weather can impact our electrical grids here on Earth. So these can provide early detection of weather, imminent weather coming in that might hit our electrical grid.
Mm-hmm. I want to go back to the kind of terrestrial forecasting capabilities this thing has. As someone who I mentioned, I am in Orlando, Florida. We are in hurricane season. Will GOES-19 be GOES-East in time to help with the efforts for this Atlantic hurricane season?
Not for this season, unfortunately. We've got a few months of checkout here to go. Once we get into geostationary orbit, We'll spend 6 months really testing out every instrument one by one, as well as the spacecraft. And that's going to take about 6 months of time. So we're estimating by January of next year that GOES 19 will be operational as GOES East. So for next season.
Hey, that's great. The one you've got up there now is great too, isn't it? So, how often, I mean, this is such an incredible system. Like, first of all, as just someone who is not involved in weather forecasting, I find myself checking out some of the public imagery from the GOES disk, and it's just like absolutely mesmerizing to see this. But I know that it's very important for other things too. It's not just for pretty pictures. How often do you have to replace these GOES satellites up there? In a long roundabout way, I'm asking, how long will GOES 19, soon to be GOES East, remain in operation up there?
Yeah, so these satellites have a mission life of 15 years, so they will meet a minimum of 15 years, but we actually fuel them for up to 20 years, sometimes 20 plus years. We can get enough fuel on them so that they last quite a long time. So GOES 19 will go out, will be operational for another 20 years, at which point it will need to be replaced, and that's where the GeoXO constellation comes in.
Mm-hmm. And can you tell me a little bit about that? What is that?
Yeah, so the GeoXO constellation, this mission is going to be the next generation of weather satellites that will replace the GOES-R fleet as the GOES-R fleet comes to its natural end of life in the 2030s. So GeoXO stands for Geostationary Extended Observations. So GeoXO is actually going to bring on board new capabilities that GOES-R didn't have. It'll maintain the imager instrument as well as the lightning mapper instrument, but it's going to bring on board an ocean color instrument, hyperspectral IR sounder, as well as an atmospheric composition instrument that are going to continue to provide not just everything we need to continue being a weather-ready nation, but also give us information on our coastlines, our oceans, more information than we've had previously from the GOES-R series.
But I'll still get those really gorgeous pictures, though, right?
Yes, yes. The beautiful imager with more color bands, as well as a lightning mapper.
Great. And where's the progress on GeoXO at this point? Is it in development? Is it hardware ready to launch? Where are we with this?
Yeah, it's currently in development. Our customer, NOAA and NASA, have been making great progress on getting these contracts placed for the instruments. They've got, I think about 3 of the 4 instruments placed, as well as the spacecraft. So they just announced a couple weeks ago the spacecraft award to ourselves, Lockheed Martin. So they have one more award to go for the lightning mapper, which is expected here in August. So by the end of this fiscal year, they'll have all of the contractors in place and starting to ready to continue the development. Now we've had phase A studies that have gotten us already pretty mature on our design, on our architecture for each of those elements. So we'll be able to hit the ground running as soon as all these contracts are placed.
Well, very exciting stuff. Jagdeep, thank you so much for bringing us up to speed on what's going on up there.
Yes, of course. Thanks for having me.
Jagdeep Shergill is the program director of GeoWeather at Lockheed Martin. That includes GOES-R and GeoXO. Still to come, repairing a spacecraft 15 billion miles away. That's ahead on Are We There Yet? You're listening to Are We There Yet? I'm Brendan Byrne. Launched in 1977, Voyager 1 has been in space for over 4 decades, sending data back to scientists from inside and outside of our solar system. But late last year, a technical issue left Voyager unable to communicate with scientists. So how do you fix a nearly half-century-old spacecraft that is 15 billion miles away? Kareem Badaruddin is the mission manager for the Voyager interstellar missions, and he's here to explain. Kareem, welcome to the show.
Thank you very much.
Glad to have you because it has been a very exciting few weeks and months for the Voyager spacecraft. But before we talk about some of the ingenious ways that you were able to communicate with the spacecraft, can you just give us a sense of where Voyager is right now?
Yeah. So, of course, we have two spacecraft. Voyager 1, it's the one that's furthest from Earth. It's about 15 billion miles away. And Voyager 2 is the one that launched first, launched about 2 weeks earlier, and it's currently about 12.5 billion miles away. They're both outside of the heliopause. They're basically outside of the solar system. They are in interstellar space. So they are the only spacecraft that anyone on Earth has in interstellar space.
That is like mind-blowing to think about that.
Yeah.
Isn't it? Like it's 15 billion miles away, launched more than 4 decades ago, zooming through space. Like that is just a wildly far trip for this spacecraft. Let's talk about when they were launched. What is it, 46 years ago at this point?
Coming up on 47 in a couple of months.
That's also wild. What was the mission objective for this pair of spacecraft?
There turns out to be a planetary alignment of the gas giant planets in our solar system, Jupiter, Saturn, Uranus, Neptune, that occurs once every 176 years. It turned out that alignment was going to occur in 1977. We never really built a probe. I mean, we were building spacecraft in those days, but really nothing of this magnitude. And I think the thought was, well, let's build 2 of them in case one of them doesn't work. And the original mission was to get to Jupiter and Saturn. It was considered if we did that would be fantastic. Voyager 1 went on a trajectory, and this was planned from the beginning to go close to Titan and get a closer look at Titan. Which took it off of the 4-planet trajectory. So it was known pretty much from the start that Voyager 1 would just get Jupiter and Saturn plus Titan, right? Voyager 2 did the Jupiter, Saturn, Uranus, and Neptune study. And Uranus and Neptune were stretch goals. All of the design documents, and we've studied quite a few design documents lately trying to solve this problem that we had, specify that every part and every system be designed to last 7 years. So that was like that's what we're trying to do. We're trying to build spacecraft that will last for 7 years. And of course, they're pushing 47 now. And I think there was the thought that maybe be out into the interstellar space, but that had to have been quite a stretch goal. I mean, some of the instruments we have are valuable. Like, for instance, we had cameras, which were very valuable in imaging the planets, but not much use when you're in interstellar space. It's not much light, but we do have instruments on 4 on Voyager 1 and 5 on Voyager 2 that do return us information about plasma and particles and waves, things that we're interested in.
That data, though, was at risk of not getting here, right? You had an issue with Voyager 1. Can you explain what were the technical issues there? What made you not hear from it anymore?
November 14, 2023, we stopped receiving data from the spacecraft. But we knew the spacecraft was pointed at Earth because we were getting the radio carrier signal. Quick summary, it was a failed integrated circuit, one integrated circuit. Each computer on the spacecraft has about 8,000 words of memory. And there was a particular chip that was responsible for 256 words. It was in there was some critical code stored in that chip. And so we had to relocate the code out of that chip and elsewhere into memory. The problem was memory is very compact and a lot of code is shared. So we had to abandon some of the code. We had to lose the ability to do something so that we could retain our ability to do most things, if that makes sense.
I'm going back to you explaining where this spacecraft is. 15 billion miles away. How did you fix it that far away?
It's quite a challenge. I mean, ordinarily, with a spacecraft, any mission maintains a test bed. And test beds are generally built to, they're much more temperamental and vulnerable to all kinds of problems. And they're built with the computers that are available at that time. So if a mission only lasts 5 or 6 years, you've got a good chance of keeping your test bed going. But when your mission lasts close to 50 years, it's very difficult. So we lost our test beds. And so this work we did, with pencil and paper. It was a large team. And the job, I explained, was to relocate the software. And we did that all by analysis. And there was a particular coder, David Cummings. Then we had others who reviewed his work. All of this was done by analysis, and all of this was done to repair a machine that's outside of our solar system. And it's interesting. There's we built 2 spacecraft, and each of them have these computers, but there are no computers like them on Earth. There's no computers like them in our solar system. The only computers like them are beyond our solar system, and so we had to fix them with pencil and paper from 15 million miles away.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with Kareem Badruddin, a mission manager for the Voyager interstellar mission, about Voyager's decades in space and its legacy, and how engineers are able to still work with Voyager even after it has left our solar system. That's wild. What is the code that you use? Is it a code that is still commonly used today in computer programming?
It's assembly language, and I think as long as there's computers, there'll always be assembly language. It's kind of a old school kind of thing.
How did you get the fix to Voyager 1? Obviously, you cannot plug in a USB jump drive to upload your fix to it at this point. How do you actually get that new code to Voyager 1 when it is 15 billion miles away?
We have the Deep Space Network, which is how we communicate with our spacecraft that are, in deep space. So it's radio signals. The spacecraft basically point at Earth, and we have antennas on Earth that receive those signals. There's actually only one antenna we use in Australia. We send the signal by radio to the spacecraft. So pretty much the same way the spacecraft talks to us, we talk to the spacecraft with radio signals from our Deep Space Network.
Now that this fix has been sent to Voyager 1, what is the prognosis? Is this a vehicle that is going to be able to continue to make scientific observations and beam them back to Earth billions and billions of miles away?
Yeah, I'm very pleased to say yes. We have returned to nominal operations. We're returning data. So the interesting thing about both Voyager spacecraft is they are always Earth pointed. They're always pointing at Earth and always sending telemetry. They're constantly sending science data to Earth. Just at Earth, we're not always listening because, I mentioned the Deep Space Network. It's used by all the spacecraft that are out there. So we have to take turns. There's not that many antennas, and all the antennas are used, most of the time. And so we get about 6 to 8 hours per day on each spacecraft, and so we're returning data on that order from both spacecraft every day, and we expect to continue to do that. Well, we'll do it as long as we can. We've got some other challenges. The spacecraft are powered by radioisotope thermoelectric generators. It's basically plutonium, and as it decays, it gives off heat. And that heat is converted into electricity, and that's what powers our computers. It powers our spacecraft. But I mentioned the word decay. So every moment, there's a little less plutonium because it's decaying. And so, every moment we've got a little less power. And so we're down to the point now where we're having to make difficult choices of what to turn off. And then the other challenge is it's extremely cold. So some things, we have heaters, and some devices that weren't originally intended to be heaters have become heaters because they're close enough to rocket fuel lines, our hydrazine lines. So we got to keep our hydrazine lines warm enough for the hydrazine to remain liquid. If the hydrazine freezes, then of course it doesn't flow, and we can't fire our thrusters. We can't control our pointing. We can't have that. We're done at that point. One day we'll be overcome, but we're trying to be as creative as we can. And as we just described the problem we solved. we're pretty creative, and we try to keep being creative and come up with ways to keep these spacecraft going as long as we can.
It's absolutely fascinating to hear you talk about that, and it's so cool that you're able to do that. And while there is a kind of a finite life to these spacecraft, you're kind of giving it all you can to keep it sending data. Finally, Kareem, I just want to ask, the public is probably most aware of the Voyager program from the pale blue dot image. As this program continues 4 decades after launch, as you mentioned, 47 years, will there be another legacy for it? What will Voyager be remembered by for this next generation, the generation after the pale blue dot?
I think there's many facets. There's many things that come to mind. But honestly, because of where we are now with our interstellar mission, where we're studying interstellar space, I mean, it took us 35 years to get to interstellar space. If anyone were to decide, hey, I'd like to study interstellar space, they've got to get funding, and they've got to, send a spacecraft out, and then they've got to wait 35 years for the spacecraft to start returning data. It's just wonderful that the original designers did such a magnificent job of building such a resilient and well-made spacecraft. I think the data we're returning from the interstellar medium is one of a kind. You could also talk about what the mission accomplished in the beginning with the planetary tour, and you can also talk about the golden record, our record that is on each of the spacecraft, a record and a record player on each spacecraft. So if someone were to collect them, there's actually instructions for how to play the record, and you can hear sounds of Earth, and there's actually digitized images, and I mean that's a whole nother thing.
So even if that plutonium runs out and the propellant freezes, it will still have some sort of lasting impact out there if some other thing were to find it, right?
That's right. It's interstellar mission is like a bonus mission. These spacecraft were built to study the gas giant planets. And then we get this bonus mission of the interstellar medium, and there will be another bonus mission of this ambassadors who are, traveling through our galaxy for forever.
Kareem, thanks so much for joining us.
Yes, it's been a pleasure. Thank you.
Kareem Badaruddin is the mission manager for the Voyager interstellar mission. Well, that's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Subscribe on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. Stay connected with the show. Be sure to follow us on social media. You can find us on Instagram and Facebook. We're at AWTY Space. Are we there yet? AWTY, get it? And if you got an idea for a future episode of the show, or you want to join us as a guest, reach out. We're at awty@cfpublic.org. We've got more coverage online. Visit cfpublic.org/space. Are We There Yet is a production of Central Florida Public Media. Our producer is Marian Summerall. Our intern is Sophie Diaz. Editorial guidance from Latoya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.